LISN, LISN, stands for Line Impedance Stabilizing Network. They are the devices for measuring conducting emissions. Today we're going through different types of LISN and have a quick general overview. My name is Min, I'm an EMC specialist, and today I'm here at Telonic and we're going through different types of LISN review. Typically speaking, we can divide LISNs into two types, AC types of LISN and DC types of LISN. Some people also like to call LISNs using their inductance value. So for example, people often call these as 50 microhenry LISNs, and people call this as 5 microhenry LISN, this one 1 microhenry LISN. We're going to explain why. Okay, so we first have a look at the AC types of LISN. This is a single-phase LISN, pretty straightforward. You can see that you plug in a single-phase powered apparatus, such as a home appliance devices, into the EUT mains port, and then you measure the conducting emission either on the live line or neutral line. Similarly, you can plug in a three-phase equipment into a three-phase LISN and you measure the conducting emission on L1, L2, L3 or neutral. We call these types of LISNs 50 microhenry simply because there is a big inductor inside this LISN and inductors inside this LISN, and they are 50 microhenry. You may ask why we have to use 50 microhenry. Well, 50 microhenry represents the wiring harness, the impedance of the wiring harness, often between the local transformer and the socket we plug in. So really, LISNs, as the name suggests, really gives you a defined impedance value of the mains network. Okay, so that's often why these are also called artificial mains network. Okay, and these are the AC types of LISN. It's also worth mentioning that when you buy these types of LISNs, they often supply you with 50 ohm terminating resistor. So when you measure noise, for example in this case on the live line, you must remember to terminate the other port with a 50 ohm resistor. Again, the purpose is to really define that impedance according to the standards. So that's AC types of LISN. Now we move to DC types of LISN. Typically speaking, we use DC types of LISN for applications such as military defense, such as MIL standards, DEF standards, or automotive standards. We also use DC LISNs. Nowadays, there are many companies who are specializing in making products for space, satellite application. We also use DC power. And typically speaking, if you go through the standards of these standards I just mentioned, they always use two LISNs. So that's why you can see here, these two LISNs are set up according to the standards. Most of the DC LISNs are 5 microhenry inductance. And as you can guess, that represents the wiring harness impedance, often between the distribution box to the voltage source. Often typically is a battery, 28 volts, 24 volts or 12 volts, depending on applications. So yeah, that's the DC types of LISN. Very similar to AC, either on the 28 volts or 0 volts or 12 volts or 0 volts, you must always terminate the other end, the other port that you don't measure with a 50 ohm terminating resistor. So that's pretty straightforward. It's also worth mentioning that for some standards, for example, like the UK defense standards, they often use LISNs as a impedance stabilizing network, okay, and then they do tests such as current probe measurement. So rather than measuring the noise directly on the LISN port, they actually terminate both with 50 ohm resistor and measure the noise using a RF current probe such as this. So this is what we call current measurement. But it is still very important to set up the test so that the impedance is fixed during tests. Otherwise, you will get different results when you test in different locations. Hence, the importance of using LISN for measuring conducting emissions. Now, we look at this very special LISN showing here. As mentioned, lots of companies these days do research and development on products such as small spacecraft or satellites. And if you go to that specific EMC standards, you will find that this type of LISN, which only has 1 microhenry inductance, okay, so representing more or less 1 meter long wiring harness. So this is a 1 microhenry LISN for that particular application. And also interesting is that if you look closer, you will see this LISN only have power P, which is the earth, and power return. There is no RF output. So in other words, you cannot really measure conducting emission from this LISN. And again, you go to the standards, you will find this one is only used to stabilize the impedance. And the standard says you must use an RF current probe to measure the conducting emission in current form. So this gives you an overview of different types of LISNs. So we cover AC LISNs, single phase, three phase. We cover different types of DC LISNs, but of course, really depends on what you do. You will probably need to go to details in terms of selecting the LISNs for your application, which we will cover in a more detailed explanation. See ya.